All right, well, let's talk about graphing square roots, okay? And here's an example of a square root, but I think I might as well just start with the basic function of y equals the square root of x, and what this is going to look like. It's going to have, if we made an xy chart, we could pick all kinds of numbers that you can easily take the square root of, like 0. What's the square root of 0? Well, 0. Let's put a 1 in there. What's the square root of 1? Yeah. Let's put a 4 in there. What's the square root of 4? 2. So if we graph those points, we've got 0, 0, 1, 1, 4, 2. And so what we find out is that the graph looks like this. All right? That's what your basic square root function graph looks like. Now, if you remember correctly, back when we were dealing with quadratics, we used this idea of h and k, and we added it and subtracted it, and we messed around with it, and it would show us where the vertex was, or in this case, where the starting point was. So the basic form of this starts to look like this now. And anytime, whatever you see here starts to move this thing left and right, and whatever you see out here starts to move it up and down. And so if we went back here, this minus 2 is outside of the square root sign. And so what it would do is it would take it down 2 units, and it would just look like this now. It would be this one moved down 2 units everywhere. And so that's called a translation. And so we can translate this by what we see, by the h and the k value. All right. We can also have letters, numbers out here, and what that starts to do is start to stretch and shrink the function. Okay. A number, I believe, if it's bigger than 1, it's going to stretch it, and if it's less than 1, it's going to shrink it. And so that's what's happening here as we start to graph square root functions. So I know that the normal square root function looks like this right here, but this tells me to go 2 to the right, and this tells me to go 5 up. So over 2, 1, 2, 3, 4, 5, here's the new function, all right? And it's all based upon what the mother function is, the basic one, and then from that, we can easily move it around depending upon the numbers for h and for k, okay? We run into the same thing with cube roots, okay? And of course, I guess you really need to know what a cube root looks like, don't you? So we can make an xy chart, and now we can actually use a negative number because I can take the square root of -1. It's -1. Excuse me, cube root of -1. I can take the cube root of 0. I can also take the cube root of +1. And so now I've got myself now, you might think that's a straight line, but it's not. It comes and goes like this. Okay? That's kind of what the cube root function looks like. And then if we start to change what's inside, or change what the h and the k are, well, now what happens here? Well, this will move it 1 to the left, and this will move it down 2. So 1 left, down 2, boom, boom, boom. That puts this point right here, this point here, this point here, and now we've got something that looks like this. So it's this same function, only it's been moved left 1 and down 2, okay? And that's how you graph square root functions and cube root functions. All right? Hope that helps.